Hello all, this is Chance Johnson, National Sales Manager. Everybody will be muted during the webinar, but there's an opportunity for you to go and post questions on your little controller on the left or the right side, wherever you have it on your computer. But what we'll do is when you give a question, I will interrupt Boris during his presentation to get the answer to the question to you. This will be recorded, and after the session, we will be sending it out to everyone that attended the webinar. Introduce you to Boris.
Okay, so I think that we can start. So hi and welcome to our webinar discussing the topic of choosing the right battery solution. We're going to review in this webinar two main technologies, the lithium-ion and the nickel-zinc, in comparison to each other and to the VRLA solution, which is still the dominant energy technology used today. We'll review some safety measures and requirements mentioned in the NFPA code, and we'll try to cover the regulations related to the lithium-ion commission.
So here's us, obviously Chance Johnson, National Sales Manager, and Boris, the Product Manager.
Yeah, my name is Boris, and I'm the Product Manager in the Critical Power Division at SolarEdge, responsible for the various energy storage solutions we use today with our UPS systems.
So today what we're going to talk about is we're going to do an overview of SolarEdge Critical Power. We're also going to talk about battery technologies being lithium-ion, nickel-zinc, and also the VRLA. We'll also touch on key considerations for the design using these technologies. Then we'll have question or times for questions at the end, but as I said, go ahead and post your questions under the questions menu, and we'll interrupt Boris during the presentation to answer those questions as we go along. So a little bit about SolarEdge overview. SolarEdge is the #1 solar inverter manufacturer in the world. We're about a 1.4, looks like about $1.6 billion company in 2021, and we have over 3,600 employees, and we're globally located. So we have decades of experience on UPS. In fact, we've got over 50 years of UPS experience of manufacturing, designing, developing, and also installing modular type UPSs worldwide. We also will talk in the future about a battery backup or UPS and ESS, where we can do peak shaving at facilities. So the background on SolarEdge Critical Power is that we are the true pioneers of the modular UPS systems. Our systems are hot swappable. As you know, other manufacturers claim they can be hot swappable, but in the end, they can tell you that you have to be in bypass. Our technology gives us the ability to hot swap power modules and DC to DC converters, also the controllers and things like that in our product. The other thing that we do is we build in a lot of fail-safe, so we can operate with or without the static switch and with or without the controller. So the B family, it's a three-phase modular system, and we come in two different voltages, the 208 volt, which is 20 to 480 kVA. That's vertically, paralleling up vertically, and then also going horizontally. The 480 volt, we go from 30 kW all the way up to 960 kW. We can scale horizontally 4 systems in a row to get these kVA ranges. So what we do is we have a complete service suite for our partners. We have people that can help in project resale. We also go over and help with project execution. And at the end, we take care of operation and maintenance of our products for our partners. So SolarEdge, we are a manufacturer. This is a nice picture of our manufacturing facility in Modin, Israel. And we also have in-house lithium-ion cell and battery manufacturing capabilities. So the one thing that we wanted to do is make it easy for our partners to work with us, because we want you to do business with us. So over the last 3 years and 2 months, we've implemented several things. Number one is a 24/7 call center. We also have spare parts depots located throughout the United States. We also have a nationwide assistance for SolarEdge sales team. We have 3 regional managers to help you with all the pre-sales and after sales. Plus, we have the ASPs covered by our own service technicians if need be.
Okay, so first of all, let's cover the basic terminology where we can cover the lithium-ion and the nickel-zinc technologies. And prior we start digging into each of the technologies, let's review the basic structure of the lithium-ion model, which is the main component unit building the battery cabinet solution. So the battery cabinet, or the battery rack, which is on the right, as it used to be called, could be split into 3 main levels. The first level is the cell level, which is the lowest level of the storage solution. It contains the relevant chemistry incorporated inside, and the cell packaging, or in other words, it is an electrochemical device that stores energy and releases this as an electricity. The second level is the battery module, which is an assembly of the battery cells connected in series or in parallel, or in a combination of both, to achieve whatever voltage and current is required for a given application. It protects the cells from external shocks, heat, or vibration. And the third level, which is the full battery cabinet, consists of modules connected in series and a BMS, which manages the voltage, current, and is responsible for the safety in the system and the communication with other devices included in the UPS. Before we start our deeper review on the lithium-ion and the nickel-zinc and their comparison, let's put a record on the most important and significant regulations related to safety and transportation. So here we have 4 main certifications split into 4 main groups. Group 1 is the safety. It deals with safety and combined with certifications and reports related to the safety of battery cabinets and UPS altogether. Group 2 deals with EMC certifications, which are flavors of EN 61000 or the FCC. And Group D is not common, but some vendors comply with it. It is a seismic certification as well, which enables systems installation in less stable areas. And Group 4 deals with transportation certifications, and it's more related to the lithium-ion. Now let's start review the battery technology offering we have. So our offering for energy storage solution used for backing up critical loads is based on 3 solutions: lithium-ion, nickel-zinc, and VRLA chemistries. Each of the offered solutions were tested and verified with the SolarEdge Critical Power UPS systems. Let's start to review each of the solutions and to compare the main features between them. So let's start with the lithium-ion. If you have any questions prior this section, you can pose them. And now we'll start with the lithium-ion solution. So simply put, why lithium-ion? These batteries are smaller, lighter, longer lasting, and more efficient. And last advances in battery development coupled with new code standards making lithium-ion more valuable choices for any deployments like data centers. And as more organizations evaluate the full picture of their capital decisions, lithium-ion becoming a compelling choice for many critical facilities. So let's start with our first aspect of the lithium-ion via the VRLA. Let's take a load of 2,250 kilowatts for relative comparison. VRLA solution takes about 83.3 feet square relative 84.6 feet square, which brings to 40% less in battery space utilization. Lithium-ion have a higher energy density, resulting in 50% to 75% reduction in footprint that can be utilized to other service or other IT equipment or to reduce facility construction costs. Lithium-ion battery system brings a significant reduction in weight comparing to VRLA, and its benefit is more significant during transportation due to obligations on max weight of trucks, containers, and shipping costs. So the bottom line here, we receive 48% less footprint. We have about 5 times lighter commissioning of system, and we have here between 2 times 2 or times 6 power density comparing to the VRLA. Another interesting aspect here, the operating temperature range, which is much higher in the lithium-ion, which lower cooling is requirement to the UPS room or the storage room, bringing to lower investment needed in the cooling the facility. Very important feature. And if we talk on the outside of temperature range support, we have here 2 charts. The left chart depicts the situation on the VRLA and the right on the lithium-ion. If we go in to the common VRLA, we have here 3 years of design life. And if we go in out of the 40 Celsius of temperature, we get here 1 year of support. While in lithium-ion, we have here only degradation to about 70%. So the bottom line here, VRLA is exposed to higher temperature, its life is cut, while in lithium-ion, we have a degradation in capacity only. We have in the lithium-ion more longer lifespan, which saves our on replacement costs and operational disruptions. Lithium-ion batteries offer an effectively battery life that is easily double that of traditional VRLA, and this alone reduces the headaches of frequent VRLA battery replacements. So what if we compare the cyclic life of both of these solutions? If we are looking on the left chart on the typical VRLA solution, looking at the 80% end of life capacity, at the 100% depth of discharge and 50% depth of discharge, we can see that our limits are between 200 and 500 cycles. Going to lithium-ion solution, just looking on the chart, one of the solutions that we provide at 80% of capacity was 100% depth of discharge and 50% depth of discharge. We can easily see that we can get about 1,000 to 2,500 number of cycles. What is a cycle? Each cycle discharge and subsequent recharge reduces its relative capacity by a small percentage. And this is how we come from 100% to the 80% with each of the cycles. Of course, when the chemistry is depleted, the cell fails and the battery must be replaced. Additional advantage that we have on lithium-ion over the VRLA is it's a really great strength of the lithium-ion, the ability to utilize its capacity on high range of discharge rates, meaning that from short backup times to very long, lithium-ion has basically the full capacity of the batteries, while in VRLA, the short backup times cannot use the full capacity available in the backup solution. And here we can see on the dotted chart of the VRLA relative to the lithium-ion, which is barely on the 100% for all backup times from the short to the long one. In addition, we have here faster recharge time, which means less time to be ready for another power failure. Some critical loads needs faster backup time recovery, and here lithium-ion can provide availability in much shorter time frames, for about 1 to 2 hours via VRLA from 6 to 12 hours. And an additional advantage of lithium-ion compared to VRLA is integrated BMS. Lithium-ion are designed with battery management capabilities, including embedded management at the cell, module, and cabinet levels. And what is the BMS is used in application generally consists of 2 levels, one monitor voltage, temperature, and current at the cell level. And this information is set up to the second level, the rack level controller that manages the safety function of the system. And the rack level BMS can rely on the battery's performing and report data which enables managers to accurately gauge the battery system health. And the VRLA, we cannot receive this information only by installing external battery monitoring, which could provide the state of health or state of charge of the batteries in terms of voltage, current, or temperature. Now, if we compare those solutions by the investments needed to cumulative expenses that related to both of the solution. So in the following chart, we can see the detailed distribution of the capital investment in VRLA compared to lithium ion. We can see that the capex investment in lithium ion is much higher on the first payment day. We can see it in the first bar. On the contrary, VRLA holds a lower capex investment, but it's clearly that it's been seen that VRLA requires additional investments in maintenance, which rarely required in lithium-ion solution. The power density of VRLA is much lower than lithium-ion solution. Thus, space utilization and lithium deployment is much better, which provide more IT loads to be accommodated in some room. And on the fourth bar, we can see that the less energy is required to cool IT rooms with lithium-ion rather than the VRLA. Minor difference, but still exists. VRLA solution requires replacements on every 3 to 5 years, which doesn't exist in lithium-ion, which is designed for much longer time frames, from about 10 to 15 years or even 20 years. Taking all of these cumulative expenses in perspective of 10 years brings the total cost of lithium-ion to be much more cost-effective than VRLA, although the initial cost was higher. And this fact shall be taken into consideration when solutions are compared for a long period of times. Now, last word regarding the BMS, prior we review some safety key regulations. The BMS is essential for the lithium-ion battery system. It's an intelligent component of battery pack responsible for advanced monitoring and management. It is the brain basically behind the battery, and it plays a critical role on all levels of safety, performance, charge rates, and longevity on the total solution. And here we can see one of the types of the BMS that we have in our systems in the battery cabinets.
Quick question, Boris. So I'm sure this is probably going to come from the field. On the battery management system, is it hooked up AC? Does it require a plug somewhere to plug up to, or do we pull the power from the batteries themselves?
So basically, I'll answer this question related to our lithium-ion solution that we provide. We have basically a very nice feature. We support one AC input with a redundant internal DC solution. So if the AC fails, we have a full DC backup for the BMS. So that I'll continue with some safety regulation based on the NFPA 855. So NFPA, it's abbreviation of National Fire Protection Association, and following items are the key considerations requirements per full list. Please refer to the relevant NFPA codes, and we'll just cover some major ones. So the NFPA 855 initially breaks down locations in two categories of indoor and outdoor. Indoor locations consider whether the building is to be used only for the purpose of containing an ESS. And the standard uses the terms dedicated use building and non-dedicated use building to describe this. If one is a non-dedicated use building, the standard requires fire-rated separation from other occupancies, which with either was the 1 or 2 hour rated wall, based on which occupancies are being separated. In addition, we have one key from the spec, 3 feet of clear space is required between every 50 kilowatt hours grouping of ESS, as well as between 50 kilowatt hours groupings and the walls of the room. Another aspect is the maximum stored energy. It's about 600 kilowatt hours in non-dedicated use buildings containing an ESS. And this shall not be exceeded from this rate. And the final aspect that we would like to mention here is that ESS installations need to be approved by authorities having jurisdiction. If not deployed under standard specification, there are some obligations on the floors of lithium-ion could be deployed, and the HAJs definitely must be in the picture to approve this. John?
So we are providing a lithium-ion solution for our UPSs. Currently, we are tested and certified to work with the B240. If you remember, that's a 480 volt box. And then the B120, which is the 208 volt box. So we have the ability to go from 5 to 10 minutes, different C rates. We have standard warranties of 5 years. We have 10 years conditional warranty. So reach out to either me or one of the regional managers to get more information on this, on pricing and availability.
Okay, so I'll make a short brief on our technical brochure, and then I think that we can make a short guided example on how to use it, because it's a very useful tool that you can use to understand the support of our battery cabinets on your loads. So on the first page on the left, you can see the main highlights of our battery cabinet and the main keys that we would like to highlight. And on the second page, which is the technical one, you can see all the options which we provide on a big table on the top, with each of the battery rack provided with all information, including the UPS that's supported by SolarEdge. Which is more interesting for you will be the backup time chart on the bottom of the page. And you can see here, we'll have on the next slide a little zoom on this table. We have here on the top column all the backup times needed, and on the left we have all the battery racks. Inside we have all the power available according to the backup time needed, and we'll cover a little bit later on how we can use this table. On the bottom of the page, you can see the TP series and TPH series, which are the two types we have, one for short backup times, one for long backup times, and the cyclic life that they support on different C rates.
So Boris, I want to interrupt you quickly. There's two questions.
Yep.
Number one, are both solutions approved for Canada, for the B240 and the B120?
Yes.
Okay. The other one is what is your availability on the Vision Revo series you are providing? So how long is the lead time to get these from order to site?
So basically, it's about 12 weeks. There's always here now an issue with the shipments, so it's about 12 weeks.
Okay. One other question, what are the maintenance, what type of maintenance is required on the lithium-ion batteries?
Okay, so lithium-ion batteries have very low maintenance requirements. There is no fluid level to measure and to maintain, nor there's no for the valve regulated as well. There's neither battery memory to be concerned about or any need to periodically cycle the batteries for calibration, their runtime. And their long life span is about 10 years or more, so it reduces the need to have to replace them over the course of the UPS period of time. By the time the batteries need replaced, it's likely time to replace the UPS as well. The included battery management system, the BMS, automatically collects and reports all the required data to accurately understand the battery system health and status, which further reduces maintenance burdens that we have with the system. So okay. I think it's a pretty clear answer.
So
let's start with the...
What about retorquing of connections, any of that?
We haven't stuck in any problems related to any torque problems with the system. Basically, it's all SPs come from time to time in order to review the deployed systems, and by the information we have gotten by now, we didn't find any problem with the torques that needed to be rechecked again.
Okay. Another question came in, are these manufactured in Israel?
Again, what is the question?
Are these manufactured in Israel?
The lithium-ion solution is provided by Vision, and they're manufactured in China.
Okay. Sorry to interrupt. Go ahead, please.
Okay, so we'll start with the guided example. Let's start to determine UPS load and require backup time. Suppose we need to back up 180 kilowatts and to backup time over about 30 minutes. Let's select the ref type that we need. So because we have two types, one for less than 10 minutes of support and one for more than 10 minutes, the TPH and the TP series, we have here a backup time of 30 minutes. So we'll choose the TP series. And now we can look at the backup timetable. So prior we understand how many battery racks we need. We can go to the table of the 30 minutes of backup time needed, and we can go to the battery rack of the TP series. The most powerful system that supplying the maximum power in this backup time required is the TP200, which provides 98.3 kilowatts. But prior we can divide and understand how many racks we need. We need to take into consideration the efficiency of the DC to AC. In our system and UPSs, the efficiency is very high, 98%. Thus, we're dividing the load by the efficiency and getting the final power needed to be backup, 184 kilowatts, divided by the 98.3, we get about 2 battery racks that needed to support this load.
Quick question.
Do you have any questions?
Yes, one quick question here. What is our policy on disposing of these batteries once they're at the end of life?
So basically, this question have been raised a lot regarding the recyclability of this units. Basically, we talk about it with Vision and their policy that's in the end of life. These batteries will be sent to their facilities. Because of the fact that these systems are still new, all the procedures is not deployed to a mass production of recyclability, but they have plans on presenting a full solution in the coming years. Because of the lifespan of their batteries for about 10 to 15 years, they have enough time to make it from small factories to high scale of recyclability.
So basically the answer is that at the end of life of these, we will be involved.
They should be supplied back to Vision to recycle them. Yes.
Okay.
Regarding nickel zinc batteries, let's start a short review in why it's important technology. So why nickel zinc? So first of all, one of the main advantages of the nickel zinc technology, it's very safe, and it's recommended in applications where physical safety is essential. Its charge and discharge rate, the nickel zinc battery chemistry excels at high discharge rates while retaining thermal stability, and is also capable of fast recharging, a key benefit of our UPS application. It's sustainable, more than 90% recyclable with no toxic chemicals, reducing toxic environmental impact. And most of these benefits that we've seen in the lithium ion are common with the nickel zinc, but there are some differences in the nickel zinc which are much better compared to the lithium ion, and now we can review them. So you can receive here with a more warranty backup with more longer lifetime. Lithium-ion batteries have long lifespan, which saves our replacement costs, but the nickel zinc has more years of support of this lifetime. Regarding Hive safety technology, there is a report that was reviewed with us on the start of this webinar, which called the 9540A, and it tests the system from cell level through module level to battery pack level. And it was found out this nickel zinc solution has no any thermal runaway during this test. This test specifically says to battery manufacturers how to test their systems in order to have a full track on how the systems were checked in the aspect of fire propagation. So nickel zinc batteries are non-flammable and fail-safe, and therefore are now subject to any travel restrictions placed on lithium-ion products. So all safe for transportation by air, over seas, and highway. And an additional advantage here of nickel zinc, it's much wider temperature support compared to lithium or the VRLA, which, as mentioned before, will lower costs on cooling required in the facilities where it's commissioned.
So the nickel zinc, we went over to zinc 5. We spent a week and a half on doing discharge, recharge, different temperatures. It was very hot there actually when we were doing all this testing, but we were able to provide 5 minutes of backup at 240 kW. I can tell you that this is a very safe battery. If you're looking at 7 minutes or less, it's a very competitive package up against the lithium ion. If you get over 7 minutes, then we're not as competitive. And the reason is the nickel zinc battery, we can do 5 to 7 minutes with one battery cabinet, where with a lithium ion, it takes 2 battery cabinets. So just as you're going out to offer this to your clients, that's something to be looking for, to providing to them.
Okay, so this is again a short review regarding the brochure of the Zinc 5 that we have, and of course it could be found on our website. The first, as you know, page depicts all the highlights of the system. And the second one is more technical, again, with all the technical data on the top, and on the bottom you can find the same backup timetable with all the time and power of this battery pack solution. Small word on the VRLA SolarEdge offering. So we have multiple battery cabinets configurations available in the North America. We have a different battery racks. They're UL 1778 and NEMA 1 certified, provided by CNC Power. We have various solutions of VRLA provided by different vendors like Energy, CNC, UASA. Typical our solutions are 12 volts cells in different capacities. So I think that you could contact our sales on different solutions that we can provide with our UPSs. Now, let's make a short comparison on the lithium ion with the nickel zinc via the VRLA. This comparison spans on 2 slides, and the factors that changes is the backup time, so it will be easier for us to understand in which situation you can decide what's the solution better for you. So taking 15 minutes as a backup time as a comparison factor, we can see that we have 3 different rack types. One rack type is Vision Lithium TP series, 15 minutes backup. The second solution in Zinc 5, 15 minutes, and the VRLA we took here for a comparison, 100 ampere hours, 60 batteries, 5 strings. So we can see here some of the parameters are normalized for easier comparison, like energy density and weight density. We can see here that the Vision provides the highest energy density. It has a max power available. Of course, the cyclic life of the Vision a little bit better than others, with a very great weight density. Though the Zinc 5 solution provides more warranty with the battery lifetime and is considered to be safer. But if we're looking at 5 minutes of backup time, we can see here that if you need more power available for short backup times, again with more warranty, which is important for you, Zinc 5 will be the compelling choice. While if you need more energy density or more cyclic solution, you can go to the Vision in 5 minutes of backup time. Remember, there is a lot there is not a perfect solution. Each one has its benefits and drawbacks depending on the site requirements and regulations we have covered before. And I think that we can conclude this webinar with the key takeaways from this session. The first one is the new technologies of energy storage available, along with the VRLA offering we have today. And now you know all the lithium ion and nickel zinc SolarEdge offering, how to use our spec sheets and to find optimal battery cabinet based on power and backup time. You can now understand the technology better, the technology and the application fit. Each case shall be considered with solid understanding of safety, power density, cyclic approach. And of course, it's very important to consider regulation and certifications with relevant HH approvals based on the national code. If you have any questions, we're here. Thank you.
So let me remind you, go ahead. We've got one question right here. Will there be a charge to send the lithium ion battery back to Vision?
Again, can you repeat?
Will there be an extra charge to send the spent battery back to Vision?
I can hear the question. I have a bad connection. Can you please ask again?
Yes. Will there be a charge to send back the end-of-life battery?
Charge. I understood. I think that this question could be checked again with the Vision, and we can reply by mail with all the answers related to this question.
Now, with Zinc 5, they have a buyback program at the end of life. So they will dispose of the batteries for you. They will provide some type of buyback from the Zinc 5 battery.
So basically regarding the Zinc 5, I think that every solution should be taken separately with the final vendor. And Zinc 5 has a different policy from Vision, and they, because of the lifespan of their system, they now, as I spoke with them, provide recyclable solutions in regular manners. They claim that regular factories for recyclable could maintain their solutions, but those questions raised to them as well, and they said that they're developing higher mass production solutions for recyclability.
Okay, so if there's any questions, please post them. We'll get to you as soon as they come in. I think I've answered every question that's on the question area. So as I stated before, everyone will get a copy of this presentation, this webinar today. In the future, if you need any more guidance or support, you can contact me, or you can contact the Western Regional Manager, which is Alan Nelson, or the Eastern Regional Manager, David Johnson. His contact is right here. You can follow that either email or cell phone, which is provided. Again, you will get a copy of this, so you will see these contact information on your copy. So I'll wait a couple more minutes and we'll see if any other questions come in, Boris. At this point, I don't see any questions coming in. So we appreciate you attending the webinar. If you have any questions, please reach out to us. Other than that, have a nice day.
Thank you.
Thank you, Boris.